Okay, let's get started. Good evening and welcome to the week 10 live session of CS104. So, I think there were some messages on chat. Let me look at that. Torch topic is too wide. How do I complete those that sir covered? I completed. Okay, I am not sure which weeks you are referring to, but if you have covered whatever was completed in class, that should be enough. PyTorch as such may have other concepts, but as long as you're at least comfortable with whatever was covered in lectures, that should be a good starting point. If you have any other questions, let me know. Okay, in the meantime, let's go to the 1 second. I think I have an issue with the slide deck. Let me just stop sharing and reshare. Give me a minute. Okay, I think it's all right now. So let's get started. Okay, let me look at this. One of the weeks is missing. Was that week 10? Yeah, you can let me know whenever you're sure of whatever you're looking for. In the meantime, let's get started. So there were a couple of questions from last week, so let's go to that. So first thing was, what is a frozen graph? So we studied this in the context of TensorRT, right? That you have a TensorFlow model and then it's saved as a frozen graph. Right. So some part of, so because this is an interdisciplinary course where the area keeps evolving, right? The curriculum is also frequently updated every year. So some portions about Dask and this whole Spark and visualizations have changed this year. So this year I think you have the NLP portion instead of this. And similarly, I think if you watch last year's lectures, I think there was federated learning for week 12. This year, there is that also has changed. I think you have something new. I think you have something on LLMs, if I'm not wrong. So there are those changes. So this part you can skip. In fact, that's something I'll talk about later today as well, because whatever we discuss in these live sessions are questions from previous assignments. So last year's week 10 actually had this whole task part. So today's questions are from there, but this time, as you see from the recap and from the course videos, the syllabus has actually changed to NLP, right? But we don't have any old questions in NLP because this is the first year that you have NLP introduced. So what I have done is I've put in some questions based on task and some other portions from last year, but they might not be very relevant because the curriculum has changed, right? So some questions where there is some commonality, like with task, they might still be useful and they might be asked, but the other questions, at least it's more like something extra for you to just know because it was there. But if you do this time's NLP assignment, I think that should help you understand the portions. So this part you need not worry about it, that should be okay. It's something that's changed as part of the syllabus. Okay, and again I'll repeat, we have three smart city project. Yes, if you do it, you can definitely add it in your CV. I haven't watched the next week's or the week after's lecture, so I'm not sure what the project is yet, but if you do it, if you're able to follow it and do it, then you can definitely add it to your CV. Yeah, so we have, other than this class, we have 2 live sessions left. So please start revising whatever you need to study for the exam. I'm guessing the exam is also this month. And if you have any doubts, any questions, please bring it up as soon as you can, so that I can kind of address it in the remaining 2 live sessions, right? And if you already have any questions and want some clarifications, please ask in chat. Again, today I think we will finish early because like I said, from the NLP portion we don't have any questions, so we'll just do the previous year's questions on task, but they might not be very relevant, so we might have extra time. So if you have questions, please feel free to ask. YouTube, there is health related project. See, whatever you do ultimately should be fine to add, even if it's not here and not there in this year's curriculum. Just make sure that you understand it well and you're able to answer any questions about it. That should be fine. Okay. Going back to the frozen graph. So here the idea is the graph and variables are converted to a single file, right? So how do you do this? These variables, some of them for instance may not even be needed during inference, right? Some of them can take constant values. So whatever can take constant values are given those constant values and saved as constants. Certain other nodes in the graph may not be needed for inference. Those are completely removed, right? And then this whole thing is saved into a single file. Now this is referred to as a frozen graph. What is the advantage of doing this? Basically, you no longer have variables in the graph, right? So you can do a lot of graph optimizations like fusion and other things that TensorRT does. So to involve optimizers such as TensorRT, you need to have this frozen graph format for TensorFlow. Week 11 collab file, again please ask on the discussion forum. I do not have any collab files, so if something was not shared in the lectures, please bring it up on the Google group. Yeah, so this is the first part, the frozen graph part. Next, what was asked was TensorRT engines, right? Understanding. So week 11 collab file, please ask on the Google group, right? I think I've pointed it out in multiple live sessions before, where there is a group where you could post a question, right? So please ask there. Or the previous one, this frozen graph. So basically the graph definition as well as the variables are converted and saved in a single file. Anything that's not needed during inference is removed and your variables are saved as constant. So this format enables a lot of graph optimizations because you remove any variables. It's a simpler way of having the entire network. Okay, let's move on to TensorRT. So this is again an optimized representation of a deep learning model, again used for inference. So not only the operations, it actually has the kernels, right? So you might have a layer, let's say a conv layer, right? Ultimately, the way it runs on the GPU is a CUDA kernel for that convolution operation, right? So TensorRT engine basically contains this kernel itself, and this kernel is designed in such a way that it exploits the knowledge of the hardware, right? So the kernel might be chosen with certain values or parameters that are hardware specific optimizations. So you can think of TensorRT engine as this optimized representation of a deep learning model that's used for inference. That's the overall idea. Okay, so I think that's all there was from last week. Any other questions before we start with this week's recap? Okay. If there are no questions, let's get started. So this week was on NLP. We had two parts, right? So we'll go through a fairly detailed recap. So many of you might be new to NLP, right? So this might kind of benefit you. So first of all, why is it called natural language, right? It's it's intended to bring out the distinction between a human language versus a programming language. So some things that are there in a natural language are things like ambiguity. What does ambiguity mean? A certain word can mean different things in different places, right? So you don't really know what is intended. It might require some contextual understanding. Yeah, so different in the sense, so there was an example of chips, I think somewhere later in the slide, right? So now if I just tell you I'm talking about chips, you don't know if I'm talking about semiconductors, you don't know if I'm talking about food. So there is ambiguity in that word and what it means, right? How do you resolve that ambiguity? Sometimes there might be some context that I can give you. For instance, if I'm telling you that I'm talking about semiconductors and then tell you about chips, then you understand that I'm talking about semiconductors. So there are various ways to resolve this, which we will see later. And again, there might be some knowledge that's required of the world to understand this. And sometimes sentences may also be ill-formed, right? Because of the way that person learns that language, or even because, for instance, when you type on text, you might not write a full sentence, right? You might skip some verbs, you might skip some phrases, and you might write something, right? And understanding this is complicated, and there is also a level of evolution. The language itself keeps evolving, right? So these are all some things that are particularly applicable to a natural language, because programming language is not like that. All of you have used programming languages by now, and you will understand that there is very little room for ambiguity. Why is that? Because a machine has to process whatever you write, right? So the machine will not be able to understand if there is ambiguity. So what we do is we have a very clearly defined syntax and rules for a programming language. So if you write it in a certain way, it's very clear to the compiler or interpreter as to what it means. Similarly, there is no knowledge needed of the world, and if you write an ill-formed program, it's simply not going to compile, right? That's how it is. So some of these things are very particular to natural languages. What is ill-formed? So if you, for instance, your sentence right now says ill-formed means, right? Without a question and without a full sentence, for instance, what is the meaning of ill-formed, right? A machine may not be able to understand this. So there is exact syntax that has to be followed in a programming language, but it is not that way in a natural language. Many times when humans talk to each other, for instance, when I read your message, I understand what you mean by what you say, right? But the way machines work is many times rule based, and it's hard to understand this sort of thing, right? So that's ill-formed. So here we will kind of, this is again a very introductory lecture, right? So we are not looking at how exactly this processing is done or what are some of the latest advances in this field. We are merely looking at what are some challenges that come with NLP and what are some initial ways of working with those challenges. That's all it is, because it's an introductory lecture. Okay, let's move on. So what is NLP? It is the computational study of language use, that is the analysis and design of computational agents that use natural languages to acquire information from other agents, human or machine. The definition might look very, very complicated, but that's all right. I think you get the meaning of it, right? So you could have so in NLP you could be trying to do one of these two, right? You could be trying to understand a natural language, which may come to you as unstructured text, right? Or you could be trying to generate natural language. So here your input is natural language. Here better useful links for NLP I can try, but again this is very, very introductory, so I'll have to see. A lot of other links I think will be we'll go into a little more detail. For instance, I think there are courses on NLP that you can take a look at. Let me see if I can find one of those. Yeah, this NPTEL course, for instance, is a very standard one on NLP. So this might help you. But again, it will go into a lot of details, right? So which you don't need for this course because it's a very introductory sort of thing. But you can go through this unstructured text to natural language understanding, structure, energy, natural. Okay, you're probably just trying to re-represent this slide, which is okay. So these are some things that you can do with NLP. So this is what we were talking about, right? How do you interpret the sentence? Hari get the hot chips, right? So there is a bit of context involved. For instance, if I was telling you that, oh, there are all of these new semiconductor companies that have come up and there's all this happening, and then I told you this sentence, you might be able to interpret chips as semiconductors. If I was talking to you about food, then this would again take on a different meaning. Again, there is some level of syntax that comes even with a natural language. For instance, all of you would have studied some form of English grammar, right, where you're taught about the subject and the predicate, the verb, the noun, the adjective, right? And again, it requires some world knowledge. For instance, you need to understand that semiconductors are referred to as chips. You need to understand what's going on in the world today, things like that. So interpreting a sentence is not a very straightforward, simple thing. Whereas in a programming language, in C, if I said printf blah blah blah, there is no doubt as to what I mean, right? The compiler will immediately be able to understand that I'm asking it to do X, Y, Z. So that's the difference between that. So again, proceeding to some of the challenges in language understanding. Lexical ambiguity. So here, this sentence looks like a tongue twister, right? It says wills, will. So this will, for instance, is a verb. This will is a noun. This will is a person. This is also a person. Again, a noun, but it's very hard to understand this, right? So there can be ambiguity because of something like this. There can be structural ambiguity. For instance, she saw her with a binocular on the hill, right? So again, interpreting this is hard because you don't know if the her with a binocular is what the sentence is trying to refer to, or she saw her with a binocular, as in the person who was seeing had a binocular, right? Impreciseness. It was really cold there. And again, you might notice some errors in the sentence as well, which is part of it, right? Because humans, when we type out, you might see many times there are mistakes. We leave out punctuation. Sometimes we mean to say something, but we skip out a couple of words, right? So impreciseness or incorrectness is also part of the challenge. Conjunction and negation. Joe likes his pizza with no cheese and tomatoes. So does this mean no cheese and no tomatoes, or does it mean no cheese and tomatoes? So that's the conjunction part. The conjunction is and, the negation is whether the no applies to the latter part as well. So all of these are a few examples. Impreciseness is like ill-formedness. Yes, in a way, yes, you can think of it as very, very similar. Okay, so there are a few more here. Referential. Joe yelled at Mike he had broken the bike. So who, right? He, is the he referring to Mike? Is the he referring to Joe? Implicature, inference, world knowledge. I was late. Conjunction is very simple, right? So we have and here. For instance, bread and butter, right? And is the conjunction. So if I said Joe likes his pizza with cheese and tomatoes, it's very clear. This person wants cheese and tomatoes with the pizza. If I said Joe likes his pizza with no cheese, That's also very clear. Now here the confusion comes because there is a negation and a conjunction. So I'm not sure if this sentence means that this person likes no cheese but likes tomatoes, or is it no cheese and no tomatoes, right? So there are a lot of such issues with understanding things. So that's the challenge that we were talking about here, conjunction and negation. Okay, going back to this part, inference or world knowledge. The sentence says, I was late because my car broke down. But to really understand this, you need to know something about the world. For instance, that this means that this person has a car, the person uses the car to get to places, the car has wheels, and it broke down, meaning it no longer works because of some fault, right? So you need to know, and a lot of this seems obvious to us, right? We don't even think that these are things that things about the world that you need to know to understand this sentence. But a lot of times when this is a task that's being performed by a machine, this becomes very non-obvious and challenging. Referential was this example. Joe yelled at Mike, he. So who the he refers to is not clear, right? That's the challenge here. Any other questions? So he could refer to Mike, he could refer to Joe, right? That's the challenge here. This implicator again means that this sentence implies a bunch of things which are not clear to somebody who does not understand these things about our world. For instance, if I say car broke down, somebody who has no idea about a car, or who has no idea about what a car looks like, what is the structure of a car, may not be able to understand this very well, right? So there are some implications that come from this sentence, that this person has a car and this person uses the car to get to places. Assume that you have no idea what a car is, what it helps you do. Then if I say I'm late because my car broke down, you're not very sure what to do with that, right? What does a car breaking down mean? Why are you late because of that? None of that is clear. So it requires some implications and some world knowledge to really understand this well. Semantics versus pragmatics. Do you know the time? Again, a lot of these things may be contextual, right? For instance, even the humor and sarcasm, you might come in half an hour late and your teacher might look at you and say, do you know what time it is? So it is not intended in a very it's intended in a very sarcastic way, rather than them really asking you for the time. But by just looking at the question, you might not be able to understand what that is. Okay, so we continue with the same thing. Here are a few more such examples. So this one is again in a certain application that you need to have. So today I think all of you are very familiar with chatbots, right? So you have ChatGPT and a bunch of things that are very similar. So here is one such example where a user says, I'm feeling very bad and want to kill themselves. And the bot replies saying it could help you with that. And then the user says, really, should I kill myself? And the bot says, I think you should. So there is some level of, here you'll notice that whatever the user wanted to ask, even though there are mistakes in that sentence, the bot has kind of understood it, right? But the only problem is the way that it is responding. So depending on the application, there are certain things that in the context of a human being becomes incorrect or unethical, right? So if someone is asking you, how do I kill myself, you expect a bot to tell you, to maybe say that, you know, this is not something I can help you with, and maybe here's something you should do if you are feeling suicidal. Contact a helpline, contact a whatever, something like that, right? Not a response like this. This is considered inappropriate. So it's not just understanding, but in the context of an application, finding a proper response. Okay, so continuing. So here's a sentence, actually a bunch of sentences, a paragraph. Napoleon was the emperor of the first French Empire. He was defeated at Waterloo by Wellington and Blucher. He was banned to St. Helena, died of stomach cancer, and was buried at Invalides. So here what is being tried is a named entity recognition. Entity can refer to the person, for instance here Napoleon is recognized as a person, can also refer to the thing here, right? First French Empire, which is labeled as miscellaneous here. It can also refer to Waterloo, which is a location, and there are a bunch of things like that, right? Person, location. So this is just an entity recognition that this is trying to do with this paragraph. Now why might this be needed? For instance, you might want some more information. For instance, you will see in Wikipedia, when there is a paragraph like this, you would have hyperlinks to all of these things, right? Because when you're reading it, you might want to read a little bit more about, say, Napoleon, or you might want to know where Waterloo is, right? So typically all of these are hyperlinked. So this is the next part of it, the information extraction and the named entity disambiguation. So here what needs to be done is which Napoleon is being spoken about, right? So you have to give a correct hyperlink. There might be multiple Napoleons. So if I just take the word Napoleon and look it up, I will find a bunch of related things, right? And there might be multiple people called Napoleon. But based on the rest of the sentence, it is possible to say with some confidence that this is what this sentence is about, and here is a hyperlink that will help you understand more, right? So this part is like that. Named entity used for understanding a particular belong to location or person name. Right, in this previous example, we are just recognizing all the named entities. Here we are kind of mapping it without any doubt to this this link, right? Disambiguation. That is the disambiguation part. So we are taking the Napoleon. Which example? Oh, the previous one, this one, right? This one is merely about the application and what is correct to say in that context, right? So here it's not about the understanding. The understanding works reasonably well. The problem is the response that is given, which is inappropriate. That's all is the takeaway from there. Belongs to natural language generation. Sure, the responses of the bot, yes. Okay, let's go back here. Any other questions so far? Is there a doubt in this slide? Next time, can you give me a slide number? That's easier. So I'm currently on 11. Do you want me to move ahead or to the previous? Okay, previous. Doesn't work very well. Yeah, sure. What is the doubt there? Humor, I think there was no example, but it's basically a joke, right? Think of any joke that you kind of say, and sometimes when you write it as a sentence, it may not be very obvious. For instance, if you're texting someone and then they make a joke, you might not know if they are joking or if they are telling you something seriously. Then you ask, are you joking, or something like that, right? So that might be a good example. And it's harder to detect these things when it's just a written sentence. Oftentimes when people speak to each other, the facial expression gives you some clarity as to whether are they joking, are they being serious. But this, you can't get that kind of information from written text. Okay, let's move ahead. Okay, this part again, with so one part is understanding the natural language. Further, after that, you could do a bunch of things. What are some of those things you could do? You could do sentiment analysis. For instance, there are a lot of social media posts these days, right? And typically they have some image or video or something like that along with a caption, and then a bunch of people might reply to that. So based on this, can you identify what is the sentiment or what is the emotion in that tweet? Is it something sad? Is it something happy? Right? That sort of thing is typically done. That is sentiment analysis. Then you could have something like spam detection. For instance, in your email clients, right? If you have Outlook or Gmail, you'll see that many times certain emails are automatically moved to your spam or junk folder. So how does the Outlook or Gmail or whatever mail client you use do that? How is it able to detect if something is spam, right? That's another technique that is used. That's also something you could do on natural language. Similarly, you could do something like relation extraction. You could do a lot of things. So yeah, these are about various applications that exist with natural language processing. Okay, so this is a comic again that kind of illustrates the same point. It's very long, so maybe we'll skip over it, but I think it's good for you to read it and see if you can understand it. So it revolves around the could care less, right? And that way, if you think about it, certain languages have certain very unique usages. For instance, English is one of those examples where sometimes a sentence seems to mean anything, but it actually means something else, right? So this is one such example. I could care less means that you actually care less, but if you actually understand the meaning of the sentence, it means that you couldn't care less, right? So it's one of those weird idiosyncrasies of the language where you're saying could but you actually mean couldn't, and someone who is speaking English for a very long time knows this, right? But if you're taught the meaning of could and couldn't and you're given this sentence, you might find it very confusing, right? That's again a challenge with natural language understanding. And every language will kind of have maybe not similar problems, but its own unique problems, right? The way, for instance, the way gender pronouns are used is different in certain languages. It relates to the subject, sometimes it relates to the object. So there are a lot of those things that are uniquely associated with the language, and that can create some problems too. So this is a comic from XKCD that you can read later. It's from the slides itself, so you can take a look at it later. Okay, so next we talk about text processing. So how do we convert natural language documents into an easy for computer format? So for instance, if it is not in a plain text format, typically you will see that, for instance, the slides today are in the PPT format, right? And typically your lecture notes are all in the PDF format. Sometimes you will see web documents in HTML, you might see Word documents, but what is easy for a computer to process is a very simple plain text format, right? What is called the ASCII or the Unicode format. So any other formats are typically converted to a plain text format. Then so this is the extraction part of it. When it comes to the cleaning part of it, words can be misspelled, right? We spoke about this already. All of us make mistakes while typing, while documents also have mistakes. So detecting that something is misspelled is also part of understanding it, right? Because if you don't understand that this is a mistake, you might interpret it as something else. And similarly, words can be in various forms. For instance, plural and singular. I might talk about a car, I might talk about cars. I might talk about my foot or feet. Might talk about mouse or mice. Now, each of these words refers to the same thing. It's only changing how many you're referring to, right? Singular or plural. Similarly, they might be in different tenses. For instance, go versus went, say versus said, right? So these are all again the same words but different in terms of plural or singular or in terms of tense. Again, you could use the same thing as an adjective or an adverb. For instance, active versus actively, rapid versus rapidly. And this is also something that we were talking about. Issues and solutions are often highly language specific. For instance, in French, you'll see a lot of syllables being written with accents on top, right? E is one of the common things I can think of, but a lot of letters are written with accents. So this is a very French specific issue, and the solution that you will propose for this will also be language specific. So these are some parts to keep in mind while we look at text processing. Okay, next, corpora refers to a data set broadly, right? The way when we talk about vision, we talk about a bunch of images being put together or a bunch of videos put together. Here we are talking about a computer readable collection of text or speech. Sometimes you might be even looking at speech, but this is an example of a text corpus or corpora, right? And again, things to keep in mind are which language is it in, is it all around one genre, and things like this. But corpora is basically that, right? A bunch of computer readable text that you have. For instance, if I take Wikipedia articles on a particular genre, maybe history, right? That could be one corpus that you use to maybe even train a model, right? But that's the idea. Okay, so let's see how much more do we have. Okay, I think we are in a good place to finish the whole recap and then take a break. So next we are talking about tokenization. So we looked at natural language in various forms, right? For instance, this is if I convert this from HTML to plain text, it is a long computer readable article on ISRO. But now, how do I go about processing this? We said that there are a lot of challenges to understanding it, but if I were to start with this, what is the first thing I do, right? So one of the first things that's commonly done after all of these error removal and misspelling removal is to split text into tokens. For instance, here is a simple way of doing it, right? The sentence says, "Who in the world am I?" Ah, that's the great puzzle. So what I do is wherever there is a white space, I just draw a line, or I kind of split it, right? I split it into tokens. So this is what I get. These are all the tokens that I get. So, and you will notice here that all the punctuation that is there is removed. So the basic tokenization method removes all punctuation, commas, full stops, exclamations, and splits at white spaces. And that white space could be just a space like here, or it could be a new line, meaning that I start the next sentence in the next line. Or you could have something like a table, and you could have the next entry in the table. I is also removed. Where is it removed? Is it removed in this sentence? No, right? You're talking about generally. So tokenization might be done in different ways, right? So we will see a little bit later as to sometimes certain words are removed because they don't contribute any additional meaning, right? That is, for instance, called stop word removal. So there are different ways in which you can do tokenization. There is no correct or wrong way to do it. So based on that, you will see that some words are removed in some forms of tokenization and retained in some forms of tokenization. It depends which method you're using. So yeah, so tokenization broadly takes some text and splits it into tokens. A type is a class of all tokens with the same character sequence. A term is a type that is included into an NLP systems dictionary. You'll understand a little more about this as we go forward. So let's do this. So we looked at a very simple form of tokenization, right? Now let's see what are some issues with that. So tokenization is again language and content dependent. So here, for instance, you have punctuation. You could remove that punctuation and it becomes boys. Now this versus this is two different meanings of the word. Here the boys refers to plural. Here the boys refers to the possessive form, right? Something that belongs to the boys. And here can't, splitting it, removing the punctuation but retaining a white space, makes it look as if it is can and a T, which again changes the meaning. So this is problematic. And you might have special things like this, which is an email address or a website. What do? Do you remove all the dots and then the slashes and if you make this one word, again it changes the meaning, right? If you make them separate words, again they lose that representation that's typically there with an email ID or a website, right? So there are a lot of such examples here, and you'll see that some things don't have spaces at all and some languages are like that. So all of these will, and some words are hyphenated, right? Good looking, good hyphen looking, coordinates. So what do you do with all of these special cases? It can actually change the meaning if you just remove the punctuation and put a space. For instance, like this, white and space. So white refers to the color, space refers to just some place, right? But when we talk about white space, many times we might be referring to the space character. Similarly, straight refers to a direction, forward also refers to moving forward. But when we say straightforward as a hyphenated word, it refers to somebody who is kind of unassuming and correct, right? So the meaning itself changes. So these are all some issues with doing a basic tokenization. Any doubts so far? Compounds. Okay. So one oh, this one. Okay. So there might be words with no spaces at all, right? Depending on the language. Like some major East Asian languages have that, where there is no space, and I'm guessing this is one of those words, or it could be a compound word in some language, I don't know. So these are just some issues or some corner cases that happen with tokenization, because we said that we would break wherever there is a space. So what if there is no space like this, right? So it's just intended to highlight that. Okay, let's move forward. Sentence segmentation. So here is another paragraph. Yeah, some languages are very difficult to do this in, and all of you, again, India is a country where we have a lot of languages, right? So in just, if you have to learn a new language, you will notice that there are some peculiarities that come with that language that may make it very hard for you as an outsider to learn that language, and it might be very easy for somebody who speaks that as their mother tongue. So again, that's the problem with languages. So this one talks about sentence segmentation. Theodore Seuss Geisel was an American children's author and cartoonist. He is known for his work writing and illustrating more than 60 books under the pen name Dr. Seuss. He completed his PhD in Lincoln College, Oxford, in English literature. So, if I asked you to kind of do a sentence segmentation, the first most intuitive approach that you think about is, let me look at a period. Wherever there is a period or a full stop, I'm going to segment it there. So this becomes your sentence 1, which is what is done here too. And he is known for his work becomes your sentence 2. He completed his PhD in Lincoln College becomes sentence 3. And this seems very simple to do. Now, what is one obvious issue that you can think about here? There are 2 dots here, right? And as humans reading this sentence, we know that these dots are referring to the degree, and a lot of degrees like PhD, MTech, BTech, whatever it is written with full stops, right? But that may not be obvious to a machine. So this might become a point of confusion, right? So now this is how do you detect the end of sentence. Do you have a lot of blank lines after the word? If it is a yes, then it is an end of sentence. If there are no blank lines, then is the final punctuation an exclamation or a question mark? If it is yes, then again it is end of sentence. If it is no, then is the final punctuation a period? And if it is a period, then is it an abbreviation like etc., or it could be something like this, right? And if it is one of those, it is not an end of sentence. So even though you have a period, if it is not an abbreviation and there is a period, then yes, it is an end of sentence. And if the final punctuation is not a period, then it's not an end of sentence. So you see that what we did very easily by just looking at the paragraph looks a lot more complicated when you look at it as a flow chart like this. But this is what you need, because otherwise there are a lot of corner cases that are encountered, right? What do I do if there is a question mark at the end of a sentence rather than a full stop? What if it's an exclamation? What if the full stop is in an abbreviation, right? All of these create problems. So you need to have a very clear definition of what constitutes an end of sentence and what doesn't, and that's what's done here. Yeah. Okay, let's continue. So next we talk about stop words, right? These are very frequent words that carry no information and thus are excluded by the system's dictionary. Examples are a, the, and, are, as, by, for, them, right? Now, why do you not get anything from these? These are required by the language. For instance, English requires that you use a or the when you're talking about things, right? This is called the article. Similarly, you have conjunctions like and, you have verbs, right? And some of those don't add a lot of meaning. Even if I remove the a or a the sentence may be grammatically incorrect, but the word itself doesn't add a lot of meaning. Those are called stop words. So what is done is these stop words are excluded from the system's dictionary. Now, how do I do this? One is I can define this explicitly. I can have a list saying stop words equal to all of these things, and then whenever you encounter them, you remove them from the system. You don't process them at all. Or it could be done a little more implicitly. For instance, you could say that the k most frequent terms in the collection are stop words, and typically that will be true. If you see a paragraph, you'll see a lot of the's, a, and things like this, right? So you could do either of these to identify stop words, and removing them can also save significant space. And but again, like, it can cause problems, right? For instance, who here may stand for the World Health Organization and may need the who, or you might just be talking about who is doing this, in which case without the it still makes sense, right? So, and if you remove in this phrase, for instance, you see a lot of stop words. For instance, be is a stop word. You could also have, so if you remove the be here, it says to or not to, which completely changes the meaning, right? So again, what is a stop word and what is not may itself be contextual and may depend on the sentence. So this is also not very easy to do. So while it may work in most cases and it might save you space, it might also result in some problems. So current trend is towards having shorter or even no stop word lists, right? Because you can avoid all such problems by simply not doing this. Okay, let's see how much more we have. Stop words, stemming, lemmatization. Okay, so let's keep going. So again, the next idea is stemming, right? So we already saw that the same word could take multiple forms depending on whether it's used in a singular or a plural. It could also take different forms on whether it's used as an adjective or an adverb. It could take different forms depending on the tense. So these are not different words, right? For instance, where was that example of yeah, this part, right? So when I talk about go and went, they actually refer to the same action, just in different tenses, right? So I want to kind of group those two as the same thing. Otherwise, my system has to learn a lot more, right? So variations of words that can be grouped together. That's the idea in stemming. So how do you do this? A crude way to do it is to cut the end of the words, and that's why it's called stemming, right? So if I have ponies, which is a plural, I cut it and then we make it pony, right? And similarly, if I have individual, we will come to lemmatization shortly and then we will talk there. I don't know exactly what is your question. So right now, this is this is a crude way of doing stemming, right? And this may not be a proper word. For instance, pony is not the singular of ponies. Pony is the singular, but that's all right. This is what is done. It's just cutting out the end of the word. Variations of the same word map to the same unique stem. So whether it's a singular or a plural or a different tense or an adverb or adjective, it would map to the same stem. That's the idea. Therefore, you have fewer root words in a sense. And here's a link to a popular stemming algorithm, and here's an example for a sentence. So it says, two households, both alike in dignity, in fair Verona, where we lay our scene, from ancient grudge break to new mutiny, where civil blood makes civil hands unclean, from forth the fatal loins of these two foes. So you see that a lot of words here, for instance, households has been made household, alike becomes ALIK, dignity is again trimmed to an I. So notice that these are not proper words sometimes. Again, the rest of it is same. Again, grudge changes, mutiny changes, hands becomes hand, and loins become loin, foes become foe, right? So this is an example of the stemming idea that we discussed. Okay, now let's look at the question on lemmatization. Can you use, okay, let's talk about lemmatization and then you will, let's come back to that question. So here again, it identifies the lemma or the dictionary form of the word. For instance, saw becomes see, and this is again very similar to stemming. So I understand the question as to whether you can directly use this. It depends on what you're trying to use, right? But in most cases I would say yes, because stemming many times gives you words that are incorrect, that are just trimmed off and given, right? Whereas lemmatization gives you the correct form of the word, the correct root word, the dictionary form, right? So lemmatization might be better than stemming, but again stemming might be much faster, right? Because here you need to kind of identify the dictionary form of the word and come up with that, which might not be very straightforward. But in stemming it's very simple. You cut off the end of the word and you're done. So depending on what you want to do and how much time you want to take with the operations, you might choose one over the other. Okay, now so saw becomes see, right? So any word can consist of a stem and affix. So the stems, as you can see here, are orange colored and the affixes are green colored. So unhappy, for instance, happy is the stem. Disrespectful, dis and full are the stems, and respect is the affix, and so on, right? So, and morphemes are the smallest meaningful units. Unhappy has two morphemes, un and happy, and disrespectful has dis, respect, and full, three morphemes. So this is again a very brief overview on lemmatization. Any other questions before we move on? No questions? Okay. For a morphologically rich language, sentence means. Which part are you referring to here? Is it this part, the full morphological analysis? With respect to the lemmatizer, okay. Let me go back to your question. For a morphologically rich language, um, so here the morphological analysis talks about kind of understanding the word and uh, coming to identify which is the stem, which is the affix, right? So that's the morphological analysis part of it. So you asked about a morphologically rich language. So I would assume that means a language that has a lot of variety in terms of this whole stems and affixes and things like that. Let me also check and see what comes up. Yeah, so I think one of the definitions I see is words are modified to indicate plurals, gender, number, tense, etc. Right? So English is one of those examples where you have a very rich morphology, as in words can take different forms depending on the tense, depending on the gender, depending on number, singular or plural. These are examples that we saw, right? So morphologically rich would mean that a language has a lot of variations of a certain word. Hope that helps. Any other questions? Okay, let's move on. Other things to keep in mind while processing. Okay, maybe now is a good time to take a break. So we are at 8:08. So we'll resume at 8:13, right? We still have a bit of recap to go over, but that's all right. Like I said today, the questions part of it won't take a long time today. So we can take a break now and resume in 5 minutes. Okay, let's continue with our recap. So other things to keep in mind during natural language processing are diacritics. So diacritics are basically these accents or these symbols that you see on top of a letter. So what do you do with them? You can remove or normalize them. For instance, you might write this just as a U, you might write this as an A, you might write this as an O. But again, this is not straightforward. Diacritics are sometimes typed using by fusing multiple characters. For instance, this U with two dots on a top is actually translates to UE. So you can't resolve it by simply removing the accent on top of U and writing it as U. Right? That's again something to keep in mind. Lower or upper casing, again United States can be written as smaller u, smaller s. You can discard the case information. And then n-grams as sequences of n characters. These are useful for Asian languages without clear word spaces, right? Where you kind of don't have that notion of a in between word inter word spaces. So that's the other thing. But these are again very small ideas. Okay, next we move on to spelling correction and edit distances. So users may not know how to spell something correctly, or there might be typing errors, or there might be, repeat what part again? Previous part. Okay, which part specifically here? First part, this part. Okay, so this is accents, right? So I don't know if you've seen them, but you typically may have noticed that some words are written with an accented E, for instance, or with an accented A, right? So these symbols on top are called diacritics. So how do you deal with them when you are processing natural language that has this? You could remove them. So these are typically, my voice is breaking, is that for everyone? Okay. So one way to deal with that is to remove the accents and just retain the letter itself, right? So you could retain U, A or O. But the problem with that is sometimes these accents, so why are these accents used? They indicate a difference in pronunciation. When you see something like this, you don't pronounce it the way you would normally pronounce E, right? That's what an accent indicates. But sometimes, in some cases, an accent indicates that multiple letters have been fused. For instance, this U is actually UE. So you can't just remove the accent on top of the letter and retain the letter itself. That's the idea here. Okay, let's move on. It's not really like a word, right? It's just removing this accent on top of the letter. You're not actually removing the word. Okay, so again, so spelling correction. So when a user types in something unknown, which is potentially a misspelled words, you can try and map it to the closest term in the dictionary. So how do you map it to the closest term? You need a notion of distance between terms. So for instance, and this distance might be by various things, right? For instance, an extra character might have been added. You can add an extra O here, for instance, or the user might have left out a character. The same O is missing, or it might be using a wrong character, I instead of O. And sometimes they might have never actually seen the word being written, so they hear it pronounced and they might try and write it the same way. So choir is how you would kind of imagine it is pronounced, right? But somebody who's never seen this word written might type it out as KWIA depending on how they've heard it spelled. So all of these are misspellings or typing errors, and you might still need to map it to the closest term in the dictionary. Lemma part or the stemming part, again I think I have skipped over that in the recap section, but go through your slides for the NLP part 2 that talks about how to do this, right? So there's a greedy programming, dynamic programming approach, I think, that helps you map and get this distance between words. So you can go through that to understand how this is done. Okay, so broadly a text pre-processing pipeline looks like this. You have tokenization. You might also do sentence segmentation before that, and you might then do either stemming or lemmatization. You might do stop word removal, and you might also do spelling correction. Diacritics, I don't know if it comes under lemmatization because it's not really I don't know if it comes under either of those. You can check and see. I'm not very sure. I would think of it more as a special case, but feel free to look it up and see if it comes to either lemmatization or stemming. Okay, so that's all I had about the recap for this week. So before we go to the questions, any other questions or comments or something that's not clear? What is the Levenstein distance between words? I think that was one of the things that was there in your slides, right? Let me take a quick look and see if I can find that. So that's a metric or a measure by which you can kind of see how many. Oh, it's a question from your assignment, is it? Okay. So by the way, when is that assignment due? Okay. General question from, I think there is a slide on this, so you can go look at it, and if you don't understand it, we'll go through the example that's given in class also. So it's a way to kind of quantitatively measure the distance between two words. So one of the applications is what we were just looking at, right? Where you have this edit distance, and if a user misspells something, then no slides were given. Is that still not updated? Let me check once. Let me check the week 10 part. Yeah, I think I still see the old slides. Yeah. Let me see if I can just put them on chat. That might help you. Okay, what I can do, I don't have edit access to this folder, so I can try and put it in the, I think NPTEL will eventually update it, but it might take some time. But since you have an assignment coming up this week, what I can do is to temporarily put it up in that same Google Drive folder that I put all my live session slides, right? So you can go take a look at that folder. I will share a link here also, and I've just uploaded it. So this has both the videos that were used in the lectures for this week. you can take a look at this, and eventually NPTEL will upload it, so then you can refer to it from the course website itself. But yeah, so in this slide, right, in intro part 2, demo file, unfortunately I don't have any of them. This also I recently got access to, so you can check on the same Google group. So this intro part 2, right, has this Levenstein distance along with an example, right? 3 or 4 slides are there, so you can go through that, and if you still don't understand it, then we can discuss it in the next week. So it's basically understanding. So if I gave you a number, right, if I gave you 9 and 10 and I asked you what is the distance between it, yeah, I don't have the demo file, that's what I'm trying to tell you. So if it's not there as part of the slides in the course, please ask on the discussion group that you have, the Google group, and the TA or the instructor who has access to that will share it there. So if I ask you what is the distance between 9 and they did not reply, in that case I'm not sure what you can do. Ask again, or maybe send a reminder message on that same group, but I definitely don't have access to it, so I don't see a way for me to do anything about this. Okay, so if I ask you a distance between numbers, right, it's very easy for you to quantitatively give me something like that. For instance, I can do 10 minus 9, or I can do absolute value of a minus b, right? This tells you how far apart those numbers are. But if I give you two words, let's say cat and dog, and I ask you the distance between cat and dog, it's hard to quantify that, right? How do I say how far cat is from dog? So this Levenstein distance is one of those metrics by which you can give a number and you can quantitatively say the distance between these two words is this much, right? So this is called edit distance. If you start editing one word and in a number of steps you go to the other word, and this step can be any of these three. It can be adding a character, it can be removing a character, it can be replacing a character, right? How many edits does it take? That's kind of the broad idea of Levenstein distance. But if it's still not clear to you, then we can go through it in one of the next sessions. Okay. Any other questions? Okay, if not, let's get started. We're already at 1.5 hours. Okay, so before we start this, I'll again give you the same thing that I mentioned at the beginning of the class. So typically all your live sessions are based on previous year's assignment questions. This time week 10's curriculum has changed to NLP, right? And week 10's last year's week 10 was basically Dask and Spark and things like that. So some of the questions that we'll discuss today may not be relevant. If you think it will help you, I can try and include maybe 3-4 NLP problems for the next week. But today we'll just go through this, so we won't go into detail into some of the answers because those portions are no longer. NLP PDF is there in the link that I shared. Please save the link because once the call ends, you will not have a. If you already have access to the live session PDFs, you've gone there, then you know the link. If not, please save the link that I sent. That link has the PDFs. Can someone confirm that they see the PDFs there? Great. So please save that link. in case you get dropped off the call or something, you'll still have it. You can go look it up later. Okay, so we won't look into detail into the answers here, because like I said, some of the answers are based on content that is no longer part of the course, but I put it here so it might be just some extra information that you learn, and in case something is asked with one of these options, you at least know what this is, right? So we won't spend too much time going through this, but let's get started. Dash is a Pythonic flexible library to distribute the workflow across multiple GPUs. CuPy, CUDF, Dask, Uzi. Any answers? C, Dask. Okay. Anyone else? C, Dask. C. Okay, everyone seems to think it's. And it is Dask, and I think this is fairly clear. I think we had an introductory slide on Dask last time. So we'll move to the next question. Dash provides uniform API around various high-performance networking libraries like InfiniBand, traditional networking protocols like TCP or shared memory, and GPU-specific protocols like NVLink, OpenUCX, OpenMPI, OpenVINO, OpenAPI. Any answers? Now I know this wasn't covered, so it's okay if you don't know or you get it wrong. D, OpenAPI. Okay. Any other answers? Okay, let's look at the answer. It is actually OpenUCX. It stands for Open Communication X, right? And if you don't know this, it's okay. Like I said, please keep this in mind. This is based on previous year's assignment, so it's just like a extra thing that you're doing. So you might not know the answers to this, and that's perfectly fine, because the curriculum has changed and some of these problems may not be relevant. It's just something that we are doing, and it might be extra information for you, not mandatory. So if you don't know, don't worry about it. Okay, so the answer to this is OpenUCX. It is a communication framework for that helps with all of these things, right? And I don't think you've heard of OpenAPI yet. OpenMPI you might have heard of in a previous lecture, and OpenVINO also probably not. So that's okay. Which of the following statements are true about Dask? Resilient, efficient, customizable, secure. You have various combinations. Any answers? A, B and D. Okay, so it's not customizable. D, all of the above. Okay. The answer is D, resilient, efficient, customizable and secure, right? Again, if you don't know any of these questions, it's okay. These are kind of extra questions. Dash is an interactive open source and browser based graph library for Python. Neo4j, Plotly, Arbor, React D3 graph. B, Plotly, Okay. B. Yes, B is the right answer. So we'll move on to the next question. Dash provides efficient feature transformations, pre-processing, and high-level abstraction that accelerates computation on GPUs using the rapid CUDF library. NB Tabular, Pandas, NCCL, NVML. Any answers? NVML, okay. Okay, let's look at the answer. It's NV tabular A. Again, this is not something that's covered. So just keep it in mind as something you learned now, and it might not still be asked because it's no longer part of the course. Next one, dataset size limitation is based on CPU memory in Pandas. State whether true or false. False. Okay. You don't understand. Again, that's okay, and I have not gone into these explanations because if I go into these explanations I'll have to essentially cover last year's week 10, right, which is no longer part of um, the course. So if you understand it, you can take a guess with the answer. True. Okay, so it is true here, and if you are curious you can go look at why this is, right. The next one, Dash integrates ETL and deep learning into a single pipeline. Spark 2.0, 3.2, Hadoop, CUDF. D, CUDF, okay. D. So it's actually Spark 3.0. Again, that's okay. Spark was again there as last year's week 10 syllabus and no longer there, so that's okay. Dash optimizes the data transfer between Spark processes. Spark SQL, Spark data frame, Spark shuffle, Spark streaming. Last question. This question was Spark 3.0. Yeah. Any answers to this question? Okay, if not, Spark streaming, okay. It is Spark shuffle. The shuffle is again one of the operations in Spark, and it is intended to kind of optimize the data transfer between processes, but that's okay, we can skip it. Dash is an industry standard data science benchmark which is used for internal performance testing. Any guesses? C. Okay, Jetson Xavier NX. Okay, C. So it's actually D, NVIDIA decision support. Jetson Xavier NX is something you've heard of. It's an edge device. MLPerf is the industry standard benchmark that is there for ML inference and training. Tau is your transfer learning one, right? Train, adapt, optimize. Decision support you've probably not at all heard of till now. So it is used in NVIDIA internally for performance testing. Okay, last question. How many nodes are present in the EGX cluster? Again, this might not have been covered in the previous ones. So EGX is again, I think, a data center hardware from NVIDIA. Just like you learnt about the Jetsons and the drives and typical GPUs, I think this one is one of the enterprise grade platforms that NVIDIA offers. So let's look at the answer. I don't think you're aware of it. So it is 8. And again, we are at the end of these 10 questions. So remember that all of these are out of syllabus, so don't expect them to be asked. It's just some extra knowledge, right? And in places where there is overlap, like Dask, you might benefit from knowing some of these things. That's all. So with this, we come to an end of today's questions. We still have 20 minutes, as I said earlier. So I'll wait for another 5 minutes before we wrap up. So last question is, how many nodes are there in the EGX cluster? For instance, you might have looked at which was that? You might have looked at an NVIDIA A100 or V100 or some of those architectures, right? And you also looked at things like DGX. EGX is one more of those. It's an enterprise offering. I don't know if what the full form is. Let me check. I think the E stands for enterprise and the GX might be graphics. I can't find a full form here, but E is definitely to do with enterprise. So yeah. So any other doubts or questions from week 10 or any of the other weeks so far? This assignment, again, like I said, it's not, if you want to solve it, there is those old slides that are there in the course lectures, right? So you can go look at that. That has content on task and the visualization part. If you go through those slides, then a lot of this might be very easy, but it's not necessary. I'm again repeating that because it's not really part of this year's syllabus. So you don't need to solve this assignment. If you're able to solve this week's NLP assignment, that is good enough. You need not really go and solve the task and the visualization part of it. Any other questions or doubts? I'll wait another 30 seconds. When will the exam be? I think I saw somewhere in the last week of October. Does anyone else know? That might be a better source. I don't know the exact date, unfortunately. I remember seeing some email from NPTEL, so you can go and look back in your inbox as to what is the date that's mentioned. Okay. If there are no other questions, then thank you so much for hyperparameter tuning. Oh, great. Sure, we can talk about that. Yeah, we will definitely cover that in the next session. Any other questions? Sure, no problem. So if you have no other questions, feel free to drop off. Thank you so much for joining and keeping it interactive, and look forward to seeing you next week.